Welcome back to the Deep Dive, the mission where we take, one of these complex, often misunderstood topics, and we just shred the sources.
And the goal is always to give you the essential, actionable knowledge you need so you can feel truly well-informed.
Today, we are strapping in for an exploration of a molecule that's, it's been a staple in sports science for decades.
For decades. But its profound importance outside of the gym is it's often ignored. You mention it in public, and people immediately picture a massive bodybuilder.
Or in an energy drink commercial.
Right.
We are, of course, talking about creatine. And while it might be the reigning king of ergogenic aids, the sources we pulled reveal this molecule with a fascinating 190-year history.
And really surprising implications that go way beyond athletic performance. We're talking cognitive health, women's health, all sorts of things.
Precisely. So at its absolute core, what are we looking at?
Okay, at its simplest, creatine is an organic compound. It's essential to energy metabolism in, all vertebrates.
And its main job?
Its fundamental job is to be a fast-acting energy reservoir. It facilitates the immediate recycling of adenosine triphosphate, or ATP.
Which is that universal energy currency of the cell. Everyone's heard of ATP.
Right. And that concept, that recycling of energy, that's the absolute key.
Before we dive into the history, can you give us a quick chemistry snapshot? The sources mention it exists in different forms, neutral and zwitterionic.
Yes, zwitterionic. And all that really means is, think of creatine as a highly charged reactive molecule.
Okay.
So the zwitterionic form is just chemistry's way of saying that the molecule has both a positive charge and a negative charge on different parts of itself at the same time.
So it cancels itself out, electrically speaking.
Exactly. It's neutral overall, but it's highly polar, and that makes it incredibly good at rapid chemical interaction, which is exactly what you need for instant energy transfer inside a muscle or, say, a brain cell.
That ATP recycling role.
Yeah.
That's our focus today. So our deep dive mission is clear. We want to extract the vital nuggets about creatine.
We're cutting through all the noise. We're going to cover how it works, what the hard science actually supports for performance, for brain function, for safety.
And finally, we're going to debunk some of the really persistent myths that are still floating around out there.
To really appreciate the story of creatine, we have to recognize this isn't some product of the 1990 supplement boom. Its history stretches all the way back to 1832.
Nearly 2 centuries ago. That's older than modern chemistry as we know it.
It is. It was first isolated by a brilliant French chemist, Michel Eugène Chevreul, and he wasn't looking for a performance enhancer.
Of course not. What was his goal?
He was simply investigating the chemical composition of animal matter. He isolated this crystalline precipitate from the basified water extract of...
Let me guess. Skeletal muscle.
You guessed it. Skeletal muscle tissue.
And he gave it the perfect name right from its source.
He did. He called it creatine, from the Greek word for meat, kreis. And that history tells you the first essential thing. This compound is intrinsically linked to our biology.
It's as natural as protein itself.
Exactly. But the real scientific momentum, the clues that it could be a supplement, that didn't start until the early 20th century.
Right, about 80 years after its discovery.
That's right. 2 Harvard researchers, Otto Folin and Willie Glover Dennis, did these crucial studies back in 1912.
And what did they find?
Something pretty dramatic. When subjects ingested creatine, their muscle creatine content just shot up. It dramatically increased.
And before that, the assumption must have been that if you ate it, you just, excreted it.
Exactly. Scientists weren't sure the body could absorb and retain it so efficiently. The fact that the muscles were able to just grab it and store it hinted at this powerful regulatory mechanism.
So the body was treating it like a precious fuel, not waste.
Precisely. Then, studies in the 1920s solidified this storage idea. And then came the discovery of its energetic partner, phosphocreatine, or PCR.
That was found in 1927.
Right, and that was the chemical turning point. It linked the molecule not just to muscle, but to rapid energy transfer. This is where researchers really started to understand the phosphagen system.
Okay, and then the final piece of that puzzle came in the 1960s with the discovery of the enzyme creatine kinase, or CK.
Yes, CK is the maestro here. It's what uses phosphocreatine to rapidly convert that low-energy ADP back into high-energy ATP. This established the whole system as the critical cellular energy buffer.
So we're shifting from the lab bench to the Olympic Stadium. Because even with all this science, creatine didn't really hit the public consciousness for a while.
Not until after the 1992 Barcelona Summer Olympics.
A classic case of science going mainstream overnight because of some high-profile wins.
It was a massive media wave.
Yeah.
The Times reported that medalists, including Linford Christie, who won gold in the 100 meters.
And Sally Gunnell, who won the 400-meter hurdles gold.
Right. They were both known users of creatine supplements.
And the public, and definitely the market, reacted instantly.
Oh, immediately. Suddenly, everyone wanted this compound. But it's important to remember the timeline here. Commercial supplements for strength didn't even hit the market until 1993.
The year after.
A year after, a company called Experimental and Applied Sciences introduced it as phosphagen. That Olympic connection turned a piece of biochemistry into a multi-million-dollar industry, almost overnight.
It's incredible how fast that happened. Okay, let's bring it back to the metabolic engine.
Okay.
If you're a supplement user, you're bypassing the natural process. But for the average person, where does this stuff actually come from?
This is so important. Creatine is not an essential nutrient. Your body makes it perfectly well on its own.
Right.
It's synthesized primarily from two amino acids,
Yeah.
glycine and arginine, but it's an intensive process that needs a third key ingredient, S-adenosylmethionine.
That's the essential methyl donor, isn't it?
Mhm.
It kicks the whole reaction into gear.
It is. It's what catalyzes that final conversion. And this whole specialized process, this machinery, it mainly resides in two organs.
Which always surprises people. You'd assume the muscles do all the work.
But it's actually the liver and the kidneys. The first step happens mostly in the kidney. The second step, the methylation, mostly in the liver. Then once it's made, it's secreted into the bloodstream for transport.
And those destinations are highly specific.
Incredibly specific. 95% of the body's total creatine and phosphocreatine stores are sequestered within skeletal muscle.
95%.
Right.
Just 5% left for the rest of the body. That just screams how important it is for muscle.
It does. And that remaining 5% is distributed to other tissues with incredibly high and immediate energy demands.
Like the brain.
The brain, the blood, and the testes. This concentration is a clear biological signal about its function. It's for tissues that need energy now.
So for the average person, what's the daily need to maintain these stores?
You need between 1 and 3 grams a day. If you have an omnivorous diet, with meat and fish, you naturally get about half of that, maybe a gram a day.
And your body just synthesizes the rest.
The rest is made internally by your liver and kidneys.
Which means vegetarians and vegans who don't get that dietary creatine, they're relying completely on their own synthesis.
That's a crucial point we'll come back to. Now, here's the piece of data that drives the entire supplement market. Your muscle creatine content is typically around 120 millimoles per kilogram of dry muscle.
Okay.
But the sources show that with consistent supplementation, you can push that storage capacity up to 160.
That's a 33% increase. That's not subtle. That is a substantial bump in available quick energy.
That is the fundamental reason for all the performance benefits. It's the difference between having, a standard engine and suddenly having a high-capacity capacitor that can deliver a massive, instant jolt of power.
That capacitor analogy is perfect.
Yeah.
Because the primary fuel, ATP, is so incredibly limited.
It's tiny. The concentration of ATP in your muscle is only about 2 to 5 millimolar.
Which is enough for what? Maybe 1 or 2 heavy reps? A few seconds of an all-out sprint.
That's it. Maybe 5 to 8 seconds. You would hit the wall almost instantly if you only relied on existing ATP. The phosphagen system, buffered by creatine, is an evolutionary necessity for this exact reason.
Let's really detail that rapid regeneration process, because this is the magic of it. During those intense moments, your body can't wait for slower processes like burning glucose.
No time for that. So phosphocreatine, or PCR, acts immediately. It rapidly donates its high-energy phosphate group to an ADP molecule.
Adenosine diphosphate.
Right, and it instantly turns it back into ATP. And the enzyme creatine kinase is the catalyst that makes this happen almost as fast as the ATP is consumed.
It's the highest speed reaction in the cell's energy toolbox.
It is. And because that PCR pool is so much larger than the ATP pool, the muscle can keep going for much longer. It's so efficient, in fact, that it's actually hard to detect changes in ATP levels during intense exercise.
Because it's being replenished the moment it dips. It's like an industrial power grid with a perfect voltage regulator.
That's a great way to put it. And this rapid buffer mechanism is why creatine monohydrate is, without a doubt, the most effective nutritional supplement for improving athletic performance.
The evidence for its ergogenic effects is maybe the most robust in all of sports nutrition,
It
right?
is. Supplementation significantly increases maximum power and performance in high-intensity, anaerobic, repetitive work.
Okay, let's break down that phrase. High-intensity anaerobic repetitive work.
We're talking about activities with short bursts of maximal effort followed by rest.
So weightlifting sets, interval training, jumping.
Exactly. Even the stop-start nature of sports like soccer or basketball,
Mhm.
in those scenarios, the performance increase is a really robust 5 to 15%.
And that range is huge. For an athlete, a 15% increase in output, or being able to do an extra rep or two on a hard set, that translates directly into bigger long-term gains.
It does. But here's the crucial distinction that often gets lost in the hype. Creatine has no significant effect on aerobic endurance. Its benefit is tied directly to that phosphagen system, which only dominates in short, high-intensity bursts. If you're training for a 10K or a marathon, creatine won't directly improve your time.
It's a tool for explosive power, specifically. Okay, let's get practical. Dosing. How does someone achieve that full muscle saturation, that 20 to 40% increase?
The sources outline two main strategies. The first, and the most common, is the rapid loading phase.
This is what you always hear about.
Right. This involves taking about 0.3 grams per kilogram of your body weight per day, and you divide that into 4 equal spaced-out doses for about 5 to 7 days.
So for an 80-kilogram person, that's 24 grams total, split into 4 6-gram doses. Why is that spacing so important?
We'll get into the pharmacokinetics, but the short answer is absorption. You want to keep the plasma concentration elevated. This approach rapidly saturates the muscles, and users usually feel a performance boost within a week.
But if someone wants a less aggressive approach, maybe to avoid that initial water weight, there's the slower method.
Yes, you can just take a much lower, constant dose, usually 3 grams per day. You'll achieve the same total muscle saturation.
But the timeline is different.
The timeline is the only difference. It takes about 28 days to fully saturate. So the performance benefits are just delayed until you hit that point.
And once you're saturated, you don't need that high dose anymore. You switch to maintenance.
Exactly. You only need to cover the small amount that degrades daily. So you drop down to a maintenance dose. Early research said 2 to 3 grams, but more modern studies, especially for bigger athletes, suggest 3 to 5 grams per day.
Okay, and a quick tip for maximizing absorption during that loading phase. The carb connection.
Yes, this is a very robust finding. Consuming carbohydrates along with your creatine significantly augments its accumulation in the muscle.
And that's because of the insulin spike.
Exactly. Insulin acts as a sort of cellular shuttle, helping to drive the creatine into the muscle cells and maximizing the uptake.
That's why you see it packaged with sugar, or why people say to mix it with juice. It's an efficiency play.
Purely to speed up that saturation.
Now, something fascinating. For a compound this well-researched, it's surprising how much we don't know about its clinical parameters.
It is truly counterintuitive. We have studied the pharmacology, what creatine does, to death. But there's this weird lack of established pharmacokinetic parameters.
So we don't have clear data on its clearance rate, volume of distribution, things like that.
Not in a systematic way for clinical dosing. We mostly rely on the outcome studies, measuring the muscle saturation. But we do have one very specific detail about its lifespan in the bloodstream.
And what's that?
It has a very short elimination half-life. It averages just under 3 hours.
3 hours, that's quick. And that explains exactly why the loading phase requires those 4 spaced-out doses.
Precisely. If you took one big dose in the morning, the plasma concentration would drop off by lunchtime. Maintaining those elevated levels is key, especially if you're thinking about continuous brain benefit, which is where we're going next.
That's a perfect segue. We're moving beyond muscle to that 5% of creatine stored in the brain. The research here suggests beneficial effects, but the evidence is it's a bit tricky to interpret.
It is tricky, mainly because the benefit seems to be context-dependent. The key finding from the data is that the greatest effect on cognitive function seems to be in individuals whose brains are already under some form of stress.
So just like with muscle, if the muscle is fresh, the gains are marginal, but if it's stressed by high-intensity work, the benefits are huge. Same thing for the brain.
Absolutely. When the brain is strained from sleep deprivation, mental overload, stress, that creatine energy buffer becomes critically valuable. It helps stabilize the neural energy supply.
And we have some pretty compelling recent data on this stress theory.
We do. A 2023 meta-analysis suggested it improved memory performance, particularly for older adults. But maybe the most illustrative finding was a 2024 trial on sleep-deprived subjects.
What did that one find?
It found that a single large dose of 0.35 grams per kilogram of body mass was enough to partially restore cognitive performance after that lack of sleep.
Wait a minute. If these trials, especially one on sleep deprivation, show a clear physiological restoration, why are regulatory bodies still hesitant? I saw that skeptical note from the EFSA.
That's a great point. It's the tension between an observed effect and a full mechanistic understanding. The 2024 EFSA opinion concluded that they can't yet establish a firm cause and effect relationship.
What's the sticking point? What mechanism are they missing?
They cite insufficient evidence on the underlying biochemical mechanisms. We see it works under stress, but the full pathway, how it specifically regulates complex processes like memory formation at a molecular level, that's not completely mapped out.
Ah, okay. So it's scientific caution. They want to know the how before they make a broad claim.
Exactly. It's scientific caution at its best.
Fair enough. Okay, moving from general cognition to neurological and muscular diseases. The results here are, well, they're pretty varied.
Definitely mixed. It underscores that creatine is a tool, not a cure-all. For some conditions, the results are quite positive. A meta-analysis on muscular dystrophies showed it increased muscle strength and potentially improved functional performance.
Which links back perfectly to its core function, giving us struggling muscle and energy buffer.
Precisely. You're upgrading a failing energy capacitor. But for other conditions, the effects are limited or even negative. In metabolic myopathies, for example, it doesn't seem to improve strength.
And for McArdle disease, it can actually be harmful.
Yes. For those with McArdle disease, high doses can impair daily living and increase muscle pain.
Why the reversal?
Well, McArdle disease involves a deficiency in glycogen breakdown, so the muscle is already energy compromised. If you flood that system with high doses of creatine, the metabolic strain of transporting it might just be too much for an already failing system.
And the research confirms it's ineffective for ALS.
That's correct. And while research is ongoing for its role in neurodegenerative diseases like Parkinson's and Huntington's,
Because of the mitochondrial connection.
right, the theory is sound. But as of a 2014 review, the evidence wasn't strong enough for treatment decisions in Parkinson's. And for Huntington's, we're still waiting on systematic reviews.
Let's shift gears completely now to a critical but often overlooked area, women's health and pregnancy. This is where some of the most compelling new research is.
This is genuinely exciting data. Recent findings suggest a significant protective effect for mothers and infants. Women consuming more than 13 milligrams of creatine per kilogram of body mass daily showed a lower risk of obstetric conditions.
A lower risk. What's the proposed physiological benefit during pregnancy?
It's multifaceted. First, it supports energy production and stabilizes maternal creatine levels. Second, it's a powerful antioxidant. But the most critical finding relates to reducing the risk of preterm birth and offering protection against perinatal brain injury.
Protection against brain injury sounds huge. How does that work?
It allows for faster cellular recovery after a hypoxic event, a temporary lack of oxygen, which can happen during a complicated birth.
So the cell has a backup power source.
It does. It can quickly restore ATP levels and maintain its integrity, which mitigates damage. It basically provides a crucial energy safety net during a high-risk event.
Before we move on to safety, we have to tackle the elephant in the locker room, the myth that creatine raises testosterone or causes balding.
Yes, this needs to be put to rest. A very strong 2021 systematic review was conclusive. The current body of evidence does not indicate that creatine supplementation increases total testosterone, free testosterone, or DHT.
And DHT is the hormone linked to male pattern baldness?
Correct. And crucially, it does not cause hair loss or baldness. The performance gains are purely metabolic, not hormonal.
Okay, now for the most critical section for any listener, safety and quality. Let's start with the immediate side effects everyone talks about.
The one well-documented, undisputed side effect is initial weight gain. In the first week of a loading phase, users will gain weight, often 1 to 3 kilograms.
And this is an osmotic effect. Water follows the creatine.
Exactly. As the muscle pulls in more creatine, it must also pull in water to maintain balance. the cell swells.
But the sources suggest this is a short-term cosmetic effect, right?
That's the important distinction. New research shows that while this initial water weight is common, long-term use doesn't really affect your total body water relative to muscle mass. The body adjusts.
The other two big myths that need to be dispelled are muscle cramps and dehydration.
Yes, these concerns have been systematically discredited by multiple reviews going back to 2008 and 2009. The evidence just doesn't support those anxieties. Creatine is not detrimental to your hydration or heat regulation.
Now, for the most sensitive concern, the one that worries doctors, renal function. Does it damage the kidneys?
This is based on a fundamental misunderstanding. Creatine's breakdown product is creatinine, which is excreted by the kidneys.
And doctors use creatinine levels as a marker for kidney function.
Right, so when you supplement creatine, you naturally elevate the amount of creatinine in your blood. This often causes a false positive reading for poor kidney function.
So we need high-quality systemic reviews to sort this out.
And we have them. A crucial 2019 systematic review investigated standard dosing from 4 to 20 grams a day across a wide array of populations: athletes, diabetics, postmenopausal women.
And the definitive finding.
The finding was clear and highly reassuring. While supplementation did result in slightly elevated creatinine levels, which is expected, those levels stayed well within normal, healthy limits.
And the conclusion.
The review concluded with absolute certainty that creatine supplementation in healthy populations at recommended doses did not induce renal damage.
That is the ultimate reassurance, and is backed by authoritative bodies.
It is. The International Society of Sports Nutrition states that long-term use, even up to 5 years, is considered safe in healthy populations, from infants to the elderly to athletes. The science is settled on this point.
Okay, so the pure molecule is stellar. But we have to talk about quality control and contamination. This is where the informed consumer needs to pay attention.
This is maybe the most actionable piece of knowledge today. The supplement industry is loosely regulated, and a critical 2011 survey of 33 commercial creatine supplements in Italy highlighted a major risk.
What did that survey find?
It found that over 50% of the tested supplements exceeded the European Food Safety Authority's recommendations for at least one contaminant. You're not always buying pure creatine.
Let's break down those contaminants. What were the most concerning ones?
Ironically, the most prevalent was creatinine, the breakdown product. This was in 44% of the samples, meaning the product was already degrading or was manufactured poorly.
A sign of a stale or sloppy product. What about the really concerning synthetic impurities?
This is where quality control is critical. About 15% of the samples had detectable levels of dihydro-1,3-triazine or high concentrations of disandiamide.
Those sound like toxic industrial byproducts.
They are. Disandiamide is a direct byproduct of cheap creatine synthesis. Its presence suggests the manufacturer did not sufficiently purify the final product.
It's evidence of cheap, non-rigorous manufacturing.
Exactly. While heavy metal contamination was low, these other compounds are why you must choose high-quality products with third-party testing. The risk isn't from the molecule itself, but from the process.
Finally, let's circle back to diet. Omnivores get about 1 gram a day. How does this benefit those on plant-based diets?
It's a huge benefit. Because creatine supplements are produced using non-animal derived materials, they're completely suitable for vegans and vegetarians.
And those groups naturally have lower muscle creatine levels.
Exactly, because they lack the daily dietary supply from meat. So they actually stand to benefit the most from supplementation. It allows them to instantly boost their stores up to that maximum level, equalizing the playing field for high-intensity training.
So what does this all mean for you? We've taken creatine from its obscure 1832 isolation all the way to the 1992 Olympic spotlight.
We've established its role as the body's fastest energy capacitor, detailed the science behind dosing, and synthesized the evidence showing its rock-solid safety record.
And its emerging cognitive benefits, especially when your brain is under stress.
The takeaway is simple. Creatine is perhaps the most well-researched, scientifically supported, and safe ergogenic aid out there. But context matters.
It's not magic.
It's not magic. It's targeted toward rapid, high-intensity work and providing crucial energetic resilience for your high-demand tissues. It's pure, reliable biochemistry.
Now, for a final provocative thought, something that connects creatine to everyday life far outside the gym. And it involves cooking, specifically grilled meat.
Creatine plays this unexpected critical role in food chemistry. When you mix creatine with protein and sugar and cook it at high temperatures above 148 Celsius, which is easy to hit on a grill, the reaction produces carcinogenic compounds.
Heterocyclic amines, or HCAs.
That's them. This reaction creates that dark, crusty char we associate with grilled flavor.
It's the creatine itself reacting.
Yes, the creatine content of the muscle tissue reacting with other elements. Food scientists actually use creatine content as an indicator of meat quality because its presence is so integral to forming these HCAs during cooking.
So it's a compound you interact with almost daily, whether you supplement or not.
Influencing everything from your cellular energy to the quality and safety of your dinner.
A compelling reminder that creatine is far more than just gym powder. It's a fundamental part of our biology. We encourage you to explore the wider implications of its role in health. Thank you for joining us on this deep dive.